The art is actually called The Art of Assembly.
The Art of Assembly.
Have you read it?
No. Which assembly is it?
It covers. It's like a 1,000-page book. It's like a lot of a lot of general concepts.
Okay. Because a lot of things are. I mean, we're like most of our 242 is basically studying conventions.
Oh.
Yeah, conventions of one particular. I mean, one particular. One particular processor, which is the Motorola processor. The one we study is. So you remember the processor we used handy boards?
Yeah.
In EC100. Yeah. That one is from the family of the ones that we really studied.
6800 or
something? Yeah, no, it's from the 68,000 and MC68000 family.
Okay.
Yeah. Wow, you can. This is pretty fucking dumb. They give you an option to share this screen. So share this screen, which means you're. Share application. Yeah, it's not working anymore. Oh, there we go. Okay. Is it recording? Yeah, it's recording. Over. You want magnetism? I did one on magnetism the other time. Did you see it? I'll just go through these points. Because I think of a new harder problem. We have situations. These are four situations. 1, 2, 3, 4. This direction, this one's going in that direction. Let's go. So just one. This is our 2, 3, 4. And we'll just put V1 is equal to V, V2 is equal to, this is not too hard on this, V3 is equal to 2V, and V4 is equal to V. Right. And what you'll have to do is find Q, 1, 2, 3, 4, all of them, with sign. Relative Q. So the relative value of Q compared to each one of them. So I mean, you're not going to find the value of Q, you're just going to find how much this Q is with respect to the other. I mean, for example, if we let this charge be Q, then what are the other charges? Or let's say it's big Q. Let's say this charge is Q is equal to big Q. What are the other three charges? Signs and magnitudes.
V is velocity?
V is velocity.
Okay. Just making sure. So.
Just the value is big Q.
Okay.
It's magnitude.
For each of them?
No, just for the two. And you want to find the other ones.
Oh,
Yeah.
okay.
You want to find how much charge of the other ones in terms of big Q.
Okay.
Higher force, higher charge, higher force, and okay.
Okay. Right. So if it's if it's a higher velocity, then it's a higher force.
Higher velocity is a higher force.
Yeah.
Okay. What's going to happen to the radius?
The radius is going to be smaller.
Smaller radius.
Yeah. Won't it? Because it'll be a tighter circle. If I think about it correctly. Hold on. Just remember the equation QVB, right? QVB.
QEB, yeah.
Yeah. So if the charge.
Technically, still higher force is going to mean higher velocity is going to mean slightly more force.
Right. Higher velocity. Is the magnetic field is the same in each of them?
The magnetic field is magnitude-wise. Let's assume it's the same. Yes.
In different directions?
Yeah, it's different direction.
Okay.
So if a charge is moving at a velocity, it should be in terms of momentum, which makes more sense because what's momentum? I don't know what momentum is. Momentum is how much the object wants to keep on moving.
Right. Yeah.
If it has higher momentum in this direction, that means it's going to take a higher force to move it from going in that direction. Right?
Yeah.
So higher velocity means higher momentum. And we're assuming the mass is the same. Higher velocity means higher momentum, which means it's going to require a higher force to move it. So if the charge starts moving at a velocity in this direction, and you apply a force on it here, let's say B is equal to 5 meters per second, start moving in that direction, you apply a force. It's not going to want to move that much, as opposed to one that's moving at a velocity of 1 meters per second. If it goes in that direction, it's going to move more from the same force, because it doesn't have that much momentum. It doesn't have as much momentum as this one.
Right.
Because when you have higher momentum, it's harder for you to stop, harder for you to move. You're
Right.
going to take more force to move something that's moving with higher momentum.
Right.
And the equation, yes, F is proportional to V also, but because the, in mathematics wise, because the centrifugal force is MV squared over R, right?
Yeah.
This is proportional to V squared, the other one's just proportional to V. So F is proportional to end of it, right? R is proportional to R is equal to MV.
Right. So.
Try not to think about it. Try not to think about it mathematics-wise. Because this, okay, since this is moving at a higher, no, it's actually the same velocity. this is moving at a higher, let's start here.
Okay.
Since this is moving at a higher velocity, right? For the same force, this is going to take a bigger radius, right? It's going to require more. If it was, if the force was the same on both of them, and this had twice the velocity, this is going to have twice the radius, right?
Right.
Because it has twice the velocity, twice the momentum, so it's going to require twice as much force to move it in the same radius, or to let it take the same curve as the other one that's moving at half as much velocity.
Right.
Okay. That means, since that's the case, that means this force must be twice as much as this force.
Okay. So twice as much as.
Twice as much as this force. Well, these have the same. Everything are the same for these. This has twice the velocity, and do that, I guess. Yeah. This has twice the velocity of this one, therefore, and it's the same radius. That means we know that the force has to be twice as much, twice as strong.
Right.
Right?
Yeah.
That means F3 is equal to 2 F4. F4 or F2. 4. Okay, F2.
Sure.
Okay, twice F2.
Which means that it'll have twice the charge.
Which means it has to have twice the charge for it to move.
Okay.
So that Q3 is equal to 2 Q4. Okay?
Yeah.
And also 2 Q. Everything else is the same for these? Yeah. 2 Q2. Okay?
Wait, so if it's 2Q2, how does it relate to the overall?
How does it relate? Yeah, how does it relate to the first Q? Right. Compare these two. It's easier to compare these two because everything else is constant.
Yeah.
Right? I mean, except R. R is something that's not constant. So P is constant.
Right.
And magnetic field is constant.
So since that radius is bigger,
force
is smaller.
Force is smaller.
Yeah.
Therefore,
the small charge.
Smaller charge, right?
Smaller.
Which means how much is the charge compared to the other ones? The radius is twice as big.
It's just proportional?
Yeah. Very proportional, so half as much charge. Yeah. So this Q, big Q, is equal to 1 over 2 of the other charges of Q, 2, 3. What's the sign on the charges?
What's the sign?
Yeah, positive, negative.
That's determined by the direction. So that one's. Hold on, give me a second. If you open the outer page, it's going up. So up outer page, so it's going to be. Wait. Hold on. Okay.
Which right hand will we use?
The curling fingers. Yeah.
Okay.
So velocity is, if we look at that point, for instance, velocity is up, right?
Mm-hmm.
Field is on the page, so force is that way.
Mm-hmm.
What does that mean?
Force is that way.
Yeah.
Okay.
To the right.
If it was positive, the force would be that way.
Oh, right, because if it's right hand, it will move. So, okay.
Oh, we don't.
But it's pointing inward.
What is pointing?
It should be pointing inward, so it's negative.
Negative charge. Which means this is.
That sounds positive.
Yeah, that sounds positive.
So that one will be negative.
Yep.
Because it's going in the pitch.
Oops.